So it wasn't very far. I was working on the market for it because now that we're not storing like
So you, there's actually some computer now. I don't know if you realize that.
so if you want to get together, just write down on paper, like just kind of like a upside down tree of how we want to do this.
Yeah.
Right, and then we can establish from there that all the types of views, at the end of that,
Oh yeah, yeah.
so we'll put that on that. So like that would mean that if it's like C, A, R, C, then R would have it's a word enabled to be true, and then D would have it enabled to be true, but A would not.
How's it? I can remember how's it set up right now. I just don't remember.
So that's I didn't get down to like the inner workings. I just like okay, it looks good. I didn't know if there was any merit in I guess because for me it's short of but there probably is like I probably should have like actually went through with like good advantage like a few examples.
I'll tell you one thing that you can do accurate where it says the out word. Because the way that works, there was restrictions. I had it in this way for the pointer. I don't know if that's exactly true. I might have know how to do it, but I think add a word could take me a little bit after.
Add a word?
Yeah.
Okay.
So after
was it were you kind of like trying to
it was some weird stuff with the reference with the pointers that were going on. So it was like setting an item to like some value. So I had like a pointer and a reference, and I was using the pointer and reference together. Whereas if it was in just the reference, you can just use it like I don't know how to actually explain this. You know, like it's really weird looking. It's really nasty looking, by the way. Like I just didn't know how to do it, so I just yeah. But with just with using reference, like anything reference.
Let's start by talking about A4 a little bit. So there was some discussion on Piazza yesterday about people that submitted unit tests and they all seemed to run, and then it said unit tests have crashed or did not run properly, which didn't seem right, but they all said okay. And some further investigation, so Google test and the -F sanitize don't seem to play together well. Now the weird thing is that a lot of people on their local machines don't see an issue with that. Like, it seems to be running okay, but for whatever reason, the Amazon Cloud Service machine is saying fsanitize like crashed, doesn't play well with ptrace and other things, and blah blah blah. And so I would just say remove those fsanitize flags from your make file. Now, I don't think I tried to go through the assignments that were submitted. I didn't think I saw anyone that actually had fsanitize everywhere and still pass. I saw some people that had fsanitize on various .o files, but maybe not like the executable and the final try-test.cpp thing. And I don't know if that was just sort of a coincidence or you figured it out on your own or something. Or did anyone else sort of learn this and maybe have any other insights into this issue? Or learn anything about this? Or is it just sort of, I don't know, someone kind of dove into this at all? No? All right, so the basic fixes don't work, including fsanitize stuff on your make files, C flags, and you should not have this issue. To be honest, if you're not doing any new stuff, you shouldn't have any of these issues anyway. So, you know, probably don't need to be worried about anything. Make sense? Questions about that? I'd still like to know why it's able to run on my local machine and not on the Grayscope machine, but we'll have to save that for another day. let's talk about maps some more. So you have a map, and let's say it's a character int m, and if I say m a equals 2, what happens at this point? Like, what's going on here? What happens to that 2?
That makes an internal copy for its structure, and then the initialized from outside can say to go where it wants to do so.
So somewhere there's some sort of pair thing that's a character int. Map makes one of these things, and the a goes to the character, and the 2 gets assigned, copied into int, and the map has that information and holds on to it, right? Now that's a primitive, so it's kind of easy to know what's happening there. If I have a map character node and T for try or something like that. That's what that would be. And I say A equals N, where N is a node. What happens here? So this node object, it's copied into some internal pair storage for this thing using a node copy construction, whether you define it or not, right? If you haven't defined it, then the default one is used. The important thing here is that whatever is inside the map and whatever this thing is are now independent as soon as that assignment happens. The copy has gone in there. So this can kind of come from anywhere you want, and you can dispose of it however you want. And once you're done with assigning it in there, it's the map that is responsible for that. If the map's responsible for it, are you responsible for it?
No.
Not a trick question. No, you're not. And that has an implication. So in assignment, you should ponder your use of the rule of 3. Right? The rule of 3 is for resources that you are responsible to manage. So these are bigger the hints that I want to get in that direction. But that is supposed to say something to you as you ponder these issues. If I said node pointer n pointer equals new node, and this is node pointer dereference. So this is a pointer to a node. This is a node object. Once you dereference it, I'm assigning that node object to this map that holds node objects. Am I responsible for the thing inside the map at this point? Because I have a new here. Am I responsible for the node in the map? What do you think? No, you're not. It's a copy of an object. And that copy should not be intertwined. Am I responsible for this thing, what this is pointing to? Yeah. That you're responsible for. But you can get rid of it right away. I could say delete node pointer on the next line, and that's okay. Right? I copied the values of this object into the map, and I said I'm done with this object. Is this the only way to get an object into a map? How else might you get it? Let's just kind of cut to the chase here a little bit, right? If I wanted to get a node that I made specially, because I need another node, and I want to get in the map, what's something I can do here at this point? Where else can you, how else do you make variables besides putting them on the heap? On the stack. How do we make a node on the stack? So here's my lines of code. I want to have this. I'm going to make n on the stack. What do I say? Node, the type. variable name. All right. This says make a note on the stack, copy its values into the map. We leave scope. That thing goes away. The map sticks around. It's a copy. This seems kind of weird in a way because it's like there's not much going on here, right? Why am I making one of these things that has no information in it, basically? Well, it's a blank node. It's waiting for you to fill it with information later. And in some ways, it's no different. If I said new node, making a new node, you're not like, oh, why are you making an empty node? You know, because you want a node. I want a node here, so I'm going to make a node. It's no different here. Right? And I will say there's a ton of you all making these pair things, which is fine. Using insert to insert this pair in there. I don't know, maybe is there some advantage to that? Or is that just like the first Google hit, how to put something on the map? I kind of love that they, twisted the normal array access notation here to be like keys here. I get a little thrill every time I write something like this. Like, man, that's so general, And then this thing where you're writing these weird template things, I get kind of all nervous about. So anyway, I don't have any preference for that, but that's the way I think about it. Put this node in this location in the map. But if you do it this way, there's also not messing around with new, you're not messing around with pointers, and you're saving yourself from having to make that resource. Questions about that? Are we good here? We're good? Push through. All right. Maybe I should. No, okay. All right, so I'm going to talk about a couple different topics here today. Mostly a little bit about inheritance, mostly the context. There's some slight differences with C++ versus like Java, for example. So it's just another thing to kind of get yourself used to. And then I'm going to talk a little about code reviews because next assignment we're going to do a code review. And I want to just sort of set the stage for that a little bit. And then we'll do a little bit of review for next quiz, which is Tuesday, right? And the review topics. All right, so plenty of stuff to get through. We'll see how we do it. So in coding, we're always trying to figure out ways to specify the relationship between chunks of code, between different objects in your system in an object-oriented sense. And there's really two main ways we do that in most programming languages. One is you say some object has some other object inside it. Like a car has an engine, right? So that specifies the relationship between these things. And we call that object composition. You compose various parts to make a larger whole. And in C++ and also in other languages, it's the instance variables, the data members, that are the way you compose other classes into your class. So for example, class car has an engine, vroom vroom thingy. And we initialize that some horsepower or something like that. All right. The other relationship is through inheritance is a kind of. So a cat is a kind of animal. You wouldn't say an animal has a cat. That doesn't make any sense really. So you don't want to have cat as a type of data member inside your animal class. You want to have some inheritance relationship between these. So cat has similar behaviors to animal, and you want to use those behaviors. Given sort of a general choice, let's say, there are things then, let's see, it's a little harder to decide where it belongs. Which is the easier one of these two to use, I guess? So if you're, just trying to build up a new class and you have these components, you want to try to like next to them through inheritance, or as put them in data members, which is sort of easier to understand, you think? It depends what it really is, I guess.
I
guess in my mind, having something and the data member is this totally separate thing is a little easier to deal with because you're saying, yeah, I've got this thing and I can call it, do things with it. At least for me, it seems easier to deal with thinking about it.
Yeah, I think most people, the reason most object-oriented classes, they start off with, hey, let's put some data inside this class, and then towards the very end, they're like, well, here's all the stuff you do for inheritance, right? And it's sort of more complicated. So I think inheritance is more complicated. I think it's valuable to learn how to think more sophisticatedly about inheritance. Even in our code smells thing, I was impressed somebody had some very nice comments about class relationships and what was a code smell. And I thought that showed some sort of good architectural knowledge of how code fits together. But in general, you should try to compose things that make sense in the context. But we're used to just throwing all sorts of stuff in our class as data members. We don't give it a second thought, basically. It's super easy to use, right? And then when you're doing inheritance, you always kind of take a deep breath and have to start drawing pictures and figure out sort of how these things fit together. All right, so inheritance is how we express as a kind of relationship in C++. And the syntax is pretty simple. Class cat, which we're used to, and then we squeeze in a colon public animal. So this says this publicly inherits from animal. And then a bunch of different terms for these relationships, right? Cat is derived from animal, and animal is the base class. Sometimes you say cat is a child class, and animal is a parent class. Sometimes cat is a subclass, and animal is a superclass. All those are sort of valid ways of talking about these relationships. And I think different languages kind of have different sort of preferences. And I'm certainly not even kind of, if you said, what's the Java way of saying this, I'd be like, superclass and subclass, right? That's sort of the Java way of describing that usually. And C++ tends to be more the child and parent or derived from base class, I think. So anyway, you see all those terms, you should see which one's like the one that's getting inherited from, which one's the lower one. So maybe let's make a quick class. And what do I want to do? We'll do the old animal cat thing, I guess, since that's what we got going on here. So class animal, and what should an animal know about itself?
Name.
Name.
Doesn't look at something.
How do you like this? I had some weird example I wanted to do. I can't remember. So let's do, well, this is integer stuff, right? It's age. Kind of boring. We need a constructor for animal. So we need a public access and animal. And we're going to have a age. And I'm going to. So this is weird here, right? Oh wait. What's weird about this initializer stuff I have going on here? Well, first of all, so you're allowed to take all the data members and, x, we had x equals x in it, and y in it, and you can have whatever data members you do in this initializer list as opposed to doing it in code. And it's somewhat, this is sort of preferred C++ way to get your data members set to some value. What's weird about this particular one?
Both the variables use the exact same name.
Yeah, there's like some scoping strangeness here, right? I should make sure this actually compiles. Because look what you can do, and then like, I can't do that. Also, what did I else forget? All right, so let's.
Yeah, I think that's
Animal. What's that? I was trying to show I'm not doing anything in the body, basically. Like a no out there. I don't really do that, but oh, I don't have any name. How quickly we forget. Also not doing anything there. Okay, that compiles, right? So this one is the data member, and this one is the local age variable. And I actually think that's kind of handy because all the times here you're like, you know, init age, you're making up some name here. You really just want to say, what's the age of this thing? And so now I can use age in two contexts. And the reason it works is that these are always the data members that you're initializing. And the local scope rules for age says use the most local age you can find. The most local age is here. All right? Not this one here. So it all makes sense in some mysterious way, but it seems weird you're allowed to do it. But I kind of like it in the sense that you're not making up random variable names just to initialize some value. So I still like that icon. This highlighting is actually super handy, right? It's going to show you what's going on. All right, so we made our animal, and let's give it a method. So boy pop. Now I only need cout. I like animal. Yeah. Watch out. So let's bring in our includes. And I'll do it that way using namespace standard. And down here, if I make an animal, Z, 10-year-old, then I say me.talk. Hopefully something will happen here. Yeah, okay. So that's inherit from animal. The question is, what do we get exactly when we inherit from? So I'm going to do class cat, and I'm going to probably inherit from animal. And what does the cat need that's different from its age and same? Lives, I heard. Okay, 9. My cat that's just having oral surgery today under anesthesia, so probably use up one of his lives, but it's supposedly got to okay. We'll add a method of oral surgery to subtract one from lives. So let's try to make a cat. You are a cat. And since it's an animal, we'll probably need some sort of constructor thing to get that age set. But when we compile it, it's going to say, there's other issues here. So there's no matching constructor to initialize cat with a single int. Okay? So the first thing is, when you inherit, you do not get the constructors from your parent class. You don't get, you don't get, we haven't really done, you don't get like the, you don't get like the assignment equals kind of thing from it. So all the sort of special things that define how these things get translated and so on don't come across. But the constructors are the big one in some sense. What do you get? You get all the member methods, and you get all the membered data members. You don't necessarily have access to them if they're private, but they're there in the object if you can manage to talk to them somehow. So cat really has all the storage of animal and its own storage for cat. And so inside it has an int age and it has a talk. It's not public, you can't access it through cat. So what do we do about our constructor? We need to make an actual constructor public. And what do we need at this point to construct our cat? There's two things, right? It has age and lives. So int age, int lives. And we're going to use initializer list. How am I going to initialize age when it's not public? So if I try to say age, so let me do age, saying like, oh, we're starting a prefix. What project do we do? If I try to do this, and lives, although it's highlighting, it makes me a little nervous that this is going to not be correct. Just say that. Wait a minute. Oh, wait, that's. Okay, so it says member initializer. This is to initialize data members. Does not name a non-static data member or base class. Basically saying, I don't know what age is. Right? I inherit from animal, but it's not public, so I can't get to it. What can I do? Make everything public? That's using the number one answer, it seems like, right? That would work.
We need like age parentheses super.
Okay, so it's how do you get to that super kind of thing like you do in Java, right? The way you do it is you actually call the animal constructor, and it constructs the animal portion of the cat. All right, so a little different than you're not doing this generic super kind of thing. You're giving very specific instructions about what you call it.
So if this, like, if you do multi-inheritance, you can say specific.
So it's equal to, we're allowed to have fully inherit, we'll talk about this another time, fully inherit two classes at once, and then you do need to kind of do this kind of game of figuring out how to, there's not one super anymore, right?
Two questions. Can you like move animal age into the body?
Yeah, so the other way to do that would have been, although actually, if I tried to say this, that doesn't work anymore because the scope now, both of them are the, this here. So I have to say init age and init lives, just to even test this out, right? And so the question is, equals init lives. This is all legal so far, right? I'm just saying build the data member this way instead of through this initializer list. Guys, try, we'll do it first, more like Python, or even call super method first. So animal and age.
Yeah, make sure 17.
No, 17.
Or full colon, sorry.
Also, my initializer list.
I was wondering.
Definition. What does that even think it is? Remove parentheses. It doesn't like whatever this is, right?
When it lives before, like should you be assigning lives to it lives?
Coming in as int lives is the
Oh, wait, no, yeah.
right. Basically, even though the messages are, you're not allowed to try to call a constructor directly like that. To assign it. So this part basically has to be in the initializer list. All right, so you're kind of free to choose how you want to fill your normal data members, either through the initializer list or through just the body of the constructor. But to really get to the animal part, you have to do an initialize.
Why do you need the public identifier?
Okay, why public? You're allowed to do a private inheritance. And I gotta tell you, every time this comes up, I read like all these things about using private inheritance in C++, and it just doesn't really stick. But I'm like, I have no idea still why you want to do private inheritance. It basically acts, when you do private inheritance, it basically acts like object composition all of a sudden. Like you don't really have direct access to any parts of it anymore. And so why, if it really is just composition, why not do composition? And there are some subtle cases where people argue that's a better way to do it. And I haven't quite like seen the light there, but it's very rare, I'll just say, right? So almost always you do public inheritance. The private thing is something, it really has some weird rules associated with it. So yeah, it's funny that there's even an option here sometimes. So this never comes up. So if I do this, so we're initializing the animal part, and then we're just filling in more details. Hopefully now we can file. Oh, that's my main. I still only call it one thing. My age first, and then my lives.
50 years, no lives lost.
Everybody start off. Okay. Now, how about this? Is that going to work?
Yeah.
I better hope so, otherwise not a lot of time to this, right? So, everyone's an animal. Let's add our own talk. So we're going to override the talk method for the base class. And see what happens here. Because my cat had surgery today, I was not allowed to have breakfast, and was very confused and upset about me not doing its breakfast. So I think about this game at this point. Okay, so I just think lost. That's pretty normal behavior, except for maybe the funny thing about the initializer constructor thing. That's the main difference we've seen. Let's try something else here. What do you want to try? Okay, so let's make a pointer to what? An animal? The cat. Okay, so let's first of all let's start with basics. Cat C. Cat pointer C equals, I'll say, I won't make a new one, I'll just point to G. Right? And I say C dot talk. Oh, not dot. Arrow. Which is point. What do you expect here? I just gave you all twice because there's two sort of tests here. Animal pointer A equals address of U. And A talk. So does that compile first of all? Yeah.
I can see it.
Okay, compiles.
Yes.
Okay, so what do we have here? We have a pointer to a cat, and obviously when you have a pointer to a cat, you say talk. It's going to say I distinct well. Here we have animal pointer to a cat, and this is, again, sort of a polymorphic kind of thing, right, where a base class can point to reference to things that inherit from that base class, certainly in Java and other languages. So you can have like one list of things, all animal pointers, and they point to dogs and cats, and those all behave how you expect them to behave in some ways. So what's going to come out of this thing? So that's opposite behavior what you get in Java, right? In Java, it's the object. It's the object that defines how that thing behaves. Now, this is not very useful from a polymorphic point of view. If you have a collection of animals pointing to different kind of subclasses, and they all say, I'm an animal, I'm an animal, I'm an animal, you don't get any differentiated behavior from polymorphic behavior, that each object behaves in the way that it should behave. So the default, again, in Java is that polymorphic behavior happens automatically. The default in C++ is that you have to tell it to allow that behavior. All right? And the way we're going to allow that behavior is make this one virtual. Now that's not exactly the same. Let's see, I'm not getting in Java, if you say it's virtual, that's only for like an abstract class, right? It doesn't come in this context where it actually isn't implemented. So we're saying this is virtual. And I don't know exactly why they're using that term, because it doesn't mean anything to me in this context. But it means, well, let's see what happens first of all. Wait, what? Oh, and the cat? Yeah. I'm allowed to have it there, actually, but it's virtual here. Okay, now it's the cat. The reason is, at compile time, the compiler decides what method gets invoked here based on the type of the thing that A is. And at compile time, that gets locked in to be the animal talk. If you declare it virtual, it does it at runtime. In other words, I can assign different things to a, I'm typing in some interactive program and I assign a dog to it or a cat to it, and it has different behavior depending on what I typed in. So there's some runtime decision making that has to happen if I've assigned a cat or dog or something to this thing. So if the animal talk is virtual, it waits until runtime and says, okay, let's go to the object that I'm pointing at, and does that thing have a talk method that I can use? And it uses the cat talk method at that time. There is a cost to this virtual. In other words, it's now a table of sort of a V table, what's called the V table, that gets looked up as the thing's running and says, hey, do you have this method on you? Yes, go ahead and use it. But it's not very expensive, and it's how this polymorphic stuff basically works. But you have an option of sort of always doing the actual type, or deferring it until it runs and it looks at the actual object and says, what do you know about talking, and it does whatever is based on there. Okay, so you're going to have to kind of, again, adjust to this idea that you have to be explicit about getting the polymorphic behavior out, and not just pretend that it's happening automatically.
There's like multiple layers, so they just go up until it finds one. You get like animal, cat, Puma, and then it would use cat instead of Puma.
Yeah, so I would not derive a Puma from a cat, but if it was animal, cat, kitten, then it goes until it finds the nearest one that it can find. I'm allowed to mark this one. So if the animal one is virtual, it's optional whether I mark this one virtual as well. I think it's kind of nice to mark that virtual to show that there has some connection to the class above. That's not necessary. All right. So once you declare the method virtual in the inheritance chain, all the overridden classes below it are also virtual at that point. And besides pointers, I can do this with references. So I can have an animal reference, aref, equal to, what is that called, u. And if I say aref dot plot, then that shows the same polymorphic behavior. There's a lot of disdain out there right now. And I would suggest you're better off making a collection of references, like just because we're doing once polymorphic stuff, also doesn't mean that we need to start using pointers again. In general, use the reference things instead, and use that to hold your base class and allow the derived classes to still express themselves. All right, so this is pretty much the same, to be honest, as other languages learn. It's just that I'd say really the only two things I have to keep in mind are how to initialize the base class, and then how to mark that I want to allow overridden classes to be accessed to the base class and still have the overridden behavior as opposed to the base class behavior. Right. This is already, just me trying to say this stuff, is like, this is why we like composition instead of inheritance, right? Because this is already much more complicated than just saying animal cat from a, that's composition of the data member of my class. But it allows certain behaviors that are nice. Let me ask this maybe. What's a good reason for doing an inheritance? What do you win by doing inheritance?
You save having to rewrite all the code.
Okay, so there's the sort of code reuse reason. And I do think that has some validity, obviously, but some people argue if you really want this code reuse, use the composition. Just suck it into your class and don't mess with the inheritance kind of thing. And there are, yeah.
I'd say abstract. It allows you to kind of abstract some details away, I guess.
So abstraction in the sense of like showing the modularity of your code explicitly. There are, again, I like to find these like blog posts, right? Like don't say x equals 2, 2 equal x and stuff. But again, people say that the only reason for doing inheritance is to allow polymorphic behavior. If you're not trying to get a collection of things with derived polymorphism, you should probably find some other mechanism to do it. So it seems like a strong point of view, but so not any good code use at all. But this idea that this is the only reason why I get this kind of stuff in here. Okay, virtual. Now we can go one step further and make this into an abstract base class. And again, an abstract base class has methods that are not implemented, and classes that inherit from it need to implement those methods. So it becomes sort of a contract as to what, how these derived classes should all behave. And so, for example, I can turn, my talk, still, yeah. You just say this. Yeah. So this says base class says everything that inherits from me is going to have a talk method. I'm not going to provide an implementation for an animal. What does the animal say? And what does the fox say? We're talking about animal says, nothing. No, we don't know it, right? So there is no specific thing an animal says. And so we shouldn't actually have an implementation for animal. It's only the derived classes that have to provide that talk method. So if I try this now, and try to make an animal, it's going to say, I'm going to talking animal, and I'm trying to make an animal. So it's an abstract class, you can't make one of these things. So I can no longer make instances of that abstract class. Directly, I can only make instances of the subclasses from it. So, that's select. Notice I can still have pointers and references from that base class, because again, they're pointing to something that actually exists, like either a cat that was nude or a local one. And so I'm not here actually making an animal, I'm just again lightweight referring to subclass either through pointer references. Right? So that starts to look more like the virtual use we're used to in some other languages. It also has said that doesn't really exist. We have to implement it. If I don't implement it, so if I say talk to, then it says I didn't actually implement it, and I'm not classically instantiated this one. All right, questions about that?
So in like Java, I don't know what it is, we can like say, you basically can put something over it and say, make sure that this was.
You can decorate it and say, this is override. And if you don't actually override it correctly, it says, you thought it was an override, but you did a typo, it's not override, right?
Right. So like, if you were here, could you like make, I mean, it's not exactly the same, it's similar, could you like make a int talk in cat, and, or like something that returns an int, right? Because now it's no longer returning void, and like, is that still?
That would not satisfy the abstract methods.
I guess we're talking about like earlier, right? Like before this was an abstract method.
Yeah.
Right. If you
Then
set
it's just its own, then it's an overload of an inherited method, right? So they have different, well actually they have to have different parameters at that point to distinguish between the two of them. You can't just do it with a return type. But if I had talk string or something like that, right, then I inherit talk that has no parameter, and then I am overloading the talk method with two different versions, different parameters. That's an overload. Override is the same name, same parameters, different in the derived class than in the base class. And for the out, it should be pretty strong. Okay, and then we can also make base classes that are pure abstract base classes, where all the methods are virtual void 0, and they act sort of like interfaces in Java, right? Where you, again, you can't make them, but you can use them to define how derived classes should behave, so that you use them in polymorphic fashion, but they all have some common set of actions that make sense for them. Okay. That's sort of, let's see, let's go to that. We call multiple inheritance later date. Had a lot of weird subtle issues. I know, and we're not going to do this. I know last semester 3505, Peter Jensen, everyone wrote like a 20-page essay on the multiple inheritance subtleties or something like that. And I don't feel like reading those, so. My opinion, let's see. Classes are cool. You know, make a vector like X, Y, Z kind of thing. That's awesome. I think it's cool. You can override operators to, make those behave like mathematical kinds of things. Inheritance can be nice, but I don't know. At a certain point, like it can go kind of overboard. And it's just too hard to understand the structure of all these subclasses and inherited things, and you don't want to make it hard for everybody else. So anyway, I mean, obviously this is all favorable. All right, so oops, I have one slide here that I wanted to change in. So for the assignment, let's look at the assignment for a second here. This is, I sort of keep saying this, it doesn't seem like it's true. There's only two parts to this assignment. You're going to connect your A4 assignment to Travis, but you didn't allow. So it's like, really, to be honest, it's like hardly anything. Although you can get Google Test up there. And so you somehow can use that YAML file to like do the commands to get cloned and CNATed and stuff like that. Except for the difficulty of trying to do those commands on a machine that you don't have direct access to, so you can see if you did what you thought you did. It's not too bad. At the end of that, Travis should be running the tests that you define for try tests every time you push something up to your repository. So if you change something there, you should go off and build it and show you that you sort of are still in good shape. All right. Then, and this is the part I'm a little scared of because I'm using a new tool that I think is a little uncertain. There's a website called CodePost, and it came out of Princeton for their like CS classes, and it's a tool to help you comment on code. And they originally designed it to be for like core staff to comment on your code. Some ways Grayscope has some similar functionality, and they don't like test. They don't do testing stuff in there. It's just for commenting on code. But I'm going to use it where it's like its own sandbox where I don't have to worry about it contaminating Grayscope or Canvas or something like that. So I'm making a course on there, and you're all going to be graders in the course. You're all course staff to yourself, basically. All right? So just hand up at me. It's just, you know. And basically, I want you to look at two submissions and do a code review on it. So evaluate the code and add some comments, and try to think of things like, when you read the variable name, does it match up with what you think is going on in the code, right? And it could be a meaningful name, but if it's like, I don't know, I see weird stuff people building up for their strings so far as they go down the recursion, different names. It doesn't mean to me it doesn't mean something that's being built up and shrinking as you search through the thing. It means it's like search string or something like that. Anyway, just think about the variable names and like, do they help you understand what's going on there? Are the methods sort of at the right level of complexity? Not too big, not too small, broken in the right place? Is the logic of the methods clear? These are all things that I'm hoping you're doing for A4 right now in your refactoring, but let's see if the other people in the class agree that, you know, you kind of took it to some final stage of niceness in some ways. Now the way that's going to happen is we have to wait for A4 to get turned in. And then I think I have to send out, and the only way I can figure out how to do this right now, but I'm going to think about it some more, is to your uib@utah.edu email. And so you get an invite to the course. And then either I'm going to add your code to the course, or you're going to upload your own submission to the course. I can't figure out what the right thing to do there is yet. And I think at that point then, you should be able to go and just grab two of these other people's and take a look at them and say nice things about them. All right? So let's talk about code review for a moment. So there's like hardly any code involved in this assignment, right? It's weird. That's part of it. Okay, so I didn't already show this one, did I? Okay, so me and my boss says I need to completely rewrite my code. It can't be that bad, surely. Here, read through this and highlight anything you think seems stupid. Sure. Yeah, that is a sad case there, right? This is not the point of code review. Right? Code review, you see the word like critique. Critique does not mean find out things that are bad. Critique means evaluate in some sense. Say what's good and say what can be improved. So it's not really trying to bring you to that. It's trying to show some insights. Keep in mind that I'm self-taught, so my code may seem a little messy. Let me see, I'm sure it's fine. Wow, this is like being in a house built by a child using nothing but a hatchet and a picture of a house. It's like a salad recipe written by a corporate lawyer using a phone autocorrect that only do Excel formulas. It's like someone took a transcript of a couple arguing at IKEA and made random edits until compiled without errors. Okay, I'll read a style guide. So, again, don't quote the criticism on this comic in your own critique, right? So code reviews, again, in a larger corporate context, have a lot of different roles. Typically, in these, someone will have some code they've been working on, and you'll meet with your team, and you'll have like a projector, and you'll show some code, and people will, and you just sort of like kind of work through it, and people will comment upon it. And sometimes this is more about like just the readability style guide kind of things. Some people might make some arguments about, this code seems going away, makes it hard to maintain. Maybe you can pick out some logical errors. Overall design and architecture. Maybe they're like performance things. Hey, you shouldn't be using this kind of data structure. This seems like something else would be good. So this is not really about bugs so much, not quality assurance's job, right? It's like trying to find ways to make the code better so that it can be used in the larger code base effectively. I think there's a lot of side benefits of this code review. So basically, you have a whole mix of experience levels in a code review. And so you might have written your code, and then someone's going to have maybe know more about the system that you're working in, and make suggestions. And so it's a way of sort of spreading knowledge amongst the team about how certain things work, or maybe even just about like whatever C++ 20 constructs might be out there that somehow work better in this thing. So building shared. So you're also often you're working in your own sort of area. I'm the person that does like the print module or something like that. And you get stuck in that little niche too long, you sort of lose track of the overall picture. And so it's good to have this larger understanding of the system by looking at other contributions that people are making. And then there's some other, funny stuff. If you know your code is going to be looked at by the people you're working with, it has this tendency to make you write like a little better code, make you care a little bit more. And that's actually called the Hawthorne or observer effect. It's just having someone kind of watching over your shoulder and make you write better code. So people do some side benefits like that. Then, so some people again are just sort of looking at pure readability stuff. Other people have a much broader understanding of what a code review does. Hey, for any of you that are in some sort of, or in an internship or working right now, does your group do code reviews? Does anyone?
Yeah, we actually had code reviews that we have to get reviewed by other people on team before we even put our code out.
So it's not like a meeting that everybody goes to. It's more like, is it sort of online or is it in person?
Yeah, so it's online. Basically, everyone has access to the repo. We do it directly online. You give your feedback, so we have to review the times.
And how do you choose the other two people? Is it always just?
I mean, sometimes it's like you go for the easy people on the team that'll go easy on you. Sometimes it's just whoever's available.
Yeah. Someone else?
Yeah, at my work, what we do is the developers will review each other's code, and depending on where that code sits, if it's in the database, then there are specific members of the team that have to have an approval on it because they have those type of rights. And if one of them pushes code, then they can approve their own, and then so they approve it, and then we.
So your code base is sort of split into little kingdoms, and there's someone who's sort of like overly responsible for that little piece in some ways.
Yeah, but they do it in pairs so that they can't just like approve their own code, so they have to have the other person approve as well.
That's interesting. Anybody else want?
Bitbucket actually helps you do a lot of code review, and so my work, whenever there's a pull request in the master, at least one person has to approve it, and then people have permissions to merge it also.
Yeah, so that's a whole other mechanism, right? Is the whole like version control, and you create some sort of barriers to just letting people do whatever they want that repositories, and there has to be some formal review before you let them like push it up and do stuff. I think that's a pretty good mechanism for a lot of these things. Right, so like I said, we use this code post system. I don't know, they kept passing me emails, so I finally gave them to them basically, so we'll see. Again, just think about just some comments. If something confuses you, you should stop and think about like why that confused you, and if you have any suggestions or how it could be done a little more clean. All right, so the scope of that assignment, see okay? You understand that? The only question to me is sort of how to push out. Oh, then to submit it, all you're going to submit is a text comment in Canvas saying who the coder is and repo And I'm assuming there's some sort of ID for these code post things that will tell you which two you reviewed. So just that. Okay. Now, the quiz on Tuesday is going to be on rule of 3. And let's just kind of want to talk about it again one more time. Maybe instead of having, well, okay, so let's just kind of discuss it for a minute, I think. Maybe you should go at some point try to write a rule of 3 for this on your own. So as you scan this, what do you see that triggers some thought process about rule of 3? There's a new in here. It's not that there's this here, right? That could just be used to traverse some existing set of on the stack kind of things. There's actually a new, and that's, again, that's not the only thing that can trigger rule of 3. Like I said, sometimes we have an open, like a file handle or something like that you need to close to clean up nicely, but this is the one that we're mostly talking about. So it has a new, and because you see that, what does that mean?
In the deconstructor, we have to say to the
So there's 3 things we need, right?
That's one.
Yeah, so you're going down and I'm going across, but we need the destructor that cleans up the allocated resource. We need the copy constructor, and we need the assignment operator. And you should know the patterns of those things. So I'm trying to destruct real quick here. What do I call this thing? Folder. Anything in here? Parameters? No, we can't really call this thing, so we just. And when does this get invoked? Okay, so when does this happen? Yeah. So if you had an object that was in some scope and you leave scope, it goes away. And the other way is the thing, the variable that is an in-holder type gets deleted. Right? Both those things make a destructor happen. What do we need to clean up in here? I just need to delete. Oh wait, class in pointer. How about bound? So we cleaned up this thing. How about this thing? What do we do here? A whole cluster over here. What's on? What do we do here? Wait for hand to twitch slightly upwards. All right.
That's created on the stack instead of the heap, so it just goes away automatically at the end when it leaves.
So it is hard to talk precisely about this a little bit because if we make our whole int holder object on the stack, these things are on the stack. If we make a whole int holder object on the heap, these things are actually on the heap as well, right? But these are automatically, when you make an int holder object through whatever mechanism, a space for an int pointer is allocated, and a space for an int is allocated, right? Which is what you're saying there, basically. And when that int holder goes away, automatically that space for the pointer goes away, and the space for the int goes away. But that says nothing about what that int pointer was pointing to, and that's what we're responsible for cleaning up. So we deleted int pointer, which means for val, what do we do? Nothing, right? We leave it alone. So don't try to write like, so delete only works on pointers. So don't try to say something like that, right? Like get the address of this thing and try to delete it. It'll try real hard to mess up your program. And this little nonsense has nothing to do with anything, basically, right? We don't care what value is stored in this int for sure. Like, just because that value comes from that object doesn't mean we have to worry about it through val or anything like that. All right, so that's all there is to it. And if this were some sort of linked list or something, that would also do everything you need to do for it, right? It would be cursed and go through there and kill everything else. What else do we need? We need a copy constructor. Looks like a constructor. And another object comes in of int holder type. And we're going to make it a const int holder reference to other. Why this instead of just an int holder?
It prevents the costly copy construction and tells that you're not actually going to edit the end holder.
Yeah, in some ways, this is a side issue from the actual copy construction going on. It means we don't know how big int holder is, and so we're going to pass it by reference so we don't copy it, and we're going to make it const because we don't want to change it back or copy it to a new object. So that's really just a performance issue. Since this is a constructor, the object we're creating has not yet had anything done to it. We're sort of initializing everything fresh. And so what do we need to copy over here? We need to say our int pointer is what? Again, this is where the key action happens. Okay? If I said what do you do with that? It's pretty sweet. Nice and simple.
For one, you need an arrow, like other pointing to it.
Well, actually, other is an object. Just because it's a reference type, not making a pointer for that. Right? I was excited for a second.
Are you gonna run into an issue where you try to do it twice and there's no copy here?
This is not doing anything different than the default copy constructor would do. Assign the value in one data member to the other data member, right? And in this case, these are both pointers to one single int that's allocated on the heap, and you're going to intertwine these two objects. Change this to one and change the other, deleting one to not allow the other one to be deleted, and so on. So if you're doing this, this is already what happens for you for free. You don't need to do that. So instead, we need to find new storage for this int that's in other, and let this thing know about it. So we make a new int out of the int that other int pointer is holding. So int pointer is pointing to an int. Let's find out what that int really is, and make a new int out of that, and assign that address to int pointer.
Could you do just int val or other dot val?
At this point, if you really know that val and int pointer are exactly the same, you can do that. But I would be worried about assuming that's always going to be true or something like that, right? And now here's the question: do I need to say this is not a resource we're managing, right? Do I need this line, or does it happen for free for us?
It will be necessary to
Yeah, you either get the default copy constructor for free and all of it, or you kill all the default behavior and you're forced to implement all the behavior yourself. It's not like you just pick and choose which parts you want to sort of name special, right? So just because val is an integer, and if all my class of integers would all happen for free, I still need to implement it here in my custom copy constructor. Okay? And then the big finale int holder reference operator equals int holder other. Thanks on the last second. So first of all, when I call this, the right-hand side, I say A equals B. A is the object that invokes this operator. B is this thing here, other. Because this is passed by value, B gets copied using this copy constructor, and this thing is an independent int holder from B at this point. Right? It has no storage there. So we're going to steal. First, let's do val, another val. Although swapping them seems a little overkill. And then we're going to swap other int pointer. I had this kind of backwards, but with int pointer. So we're saying other holds a new independent int. We're going to steal that int for our data member, give the other one our old one, and then leave scope, and other destructs our original value, cleans it up for us, and we hold on to the other one instead.
You don't want to leave scope just yet.
I got to return this. All right, but these two interact very tightly. That's how they perform. All right. So I just I'm not really expecting you to just kind of write them all out from scratch. You know, like the subtleties and syntax stuff.